Hello. If there's anyone there, if you can please just type in the chat, I would appreciate it. I'm going to wait a couple of minutes to see if anyone shows up before I start. All right, I'm going to go ahead and get started. And that way I can just go ahead. Hey, Seth, how you doing? Welcome. Hello, Tori. Oh, dear Lord. Welcome. Welcome. It's good to see everyone here. All right, so I'm going to go ahead and get started so that I want to respect everyone's time. Thank you for coming. Okay, so we're going to go over the review guide. So you should have your review guide with you. This is being recorded, so I will actually post it to the channel afterwards. Okay? Define the difference between an independent variable and a dependent variable in a scientific experiment. So an independent variable is the variable that you are controlling. Okay? The dependent variable is the variable or the outcome variable. Okay? In other words, the result of the experiment. All right? Now, describe an experiment that tests speed effects on collisions and identify an independent and dependent variable in your experiment. So one of the, welcome to everyone who has come in. Feel free to type your name in the chat. Just kind of let me know who's shown up. So for number 2, if you look at experiment 76, that is an example of speed effects on collisions. So when the cart was going down on the block, it hit the block, and then you saw how far the block went. The faster the cart was going, the harder it hit the block, and the further the block went again down the track. Okay, so the independent variable was the ramp height. Okay, in other words, if you started at point C versus point A, the higher you started up at the point of the ramp, the further the block went because the harder you hit. Okay, and the dependent variable was the distance the block traveled. Okay. Number 3, describe an investigation that could test the force strength and identity of the independent and dependent variable in your investigation. So this was activity 81. So activity 81, this was actually a video that we looked at. So you had the block and you had the 2 springs. And the video is actually in I actually have one of the videos recorded, but if you look at the springs, you actually had to pull the spring. Okay, I'm not sure what you mean by that. But if you pull the spring, you could actually see how many newtons it took to actually move the cart or move the block. So that was the force slab that they're talking about there. Okay, so the independent variable was the amount of force applied to the wooden block, and the dependent variable was the resulting motion. So if you pull with an unbalanced force, the object will move more in the direction of the greater force. Okay, so that would be your hypothesis. So, what do you need to consider when conducting a scientific investigation to ensure your results are reliable? Okay. Oh, what if it's a steel block? Well, it doesn't matter if it's a steel block. The only thing that's going to change there is the coefficient of friction between the block and the surface. But the type of block is irrelevant. Ultimately, what's going to happen is, and of course, the mass of the block matters, but ultimately, what's going to happen is when you have that block on the surface and you have it hooked into the scale, as you're pulling it, the force is what's going to cause it to move. Okay, so how much force is needed to overcome the friction between the block and the surface and the mass of the block to get the block to move? That's what's important. Does that make sense? And of course, you can ask any questions you want in the chat. Okay, so I have the chat open. So you can ask any questions you want in the chat, and I'm keeping an eye on it. Okay. So getting back to number 4, what do you need to consider when conducting a scientific investigation to ensure your investigation results are reliable? You need to, number 1, test only one variable at a time. Okay. And number 2, use multiple trials. Number 1, you're testing one variable because if you test more than one variable, you're not going to know which variable was responsible for the result you're looking for. Number 2, using multiple trials, you want to make sure that your results are actually accurate and you're getting consistent results. Okay? So number 5, when carrying out a scientific experiment, the outcomes are more valid when the results of multiple trials are consistent. If another scientist carries out the same investigation and gets the same outcome, the results of the experiment are even more valid. In your own words, distinguish between repetition and replication. Replication is when someone takes your experiment and recreates it. So they take your exact experiment and they perform it. Repetition is when you perform your own experiment over and over. I see some comments here. Tori, let's keep it to the science, please. Okay. When graphing variables, which variable is on the y-axis and which variable is on the x-axis? So the dependent or the responding variable is on the y-axis, and the manipulated or the independent variable is on the x-axis. Correct. There you go. All right. So what should a scientist do if their hypothesis is not supported? Okay. So I got a friend. All right. So if a hypothesis is not supported, yeah, they're playing a game to keep them from barking so loud in the video. So, and apparently his rope got tossed over here. So if a hypothesis is not supported, the experiment should be redesigned after reviewing the results. So yes, your data should be reported, but if your hypothesis is not supported, you should redesign the experiment after reviewing your results. What's the matter? I cannot add anyone on Discord. What are some examples of models we have used in class? List the benefits and limitations of each. Okay. We have used so many models in class, and there's so many different types of models. So this is important to look at. We have done dozens of experiments in class. So if you look at the forces and motions labs alone, the track, the carts, all of those were models. You remember the cloth? The cloth simulated braking. Okay, so that was important. Ow. What did you get me with? It's right here. Knox. Okay. So the HR diagram. Yes, that was another model. Awesome. Okay, so the HR diagram, any of those computer generated models, those are all models. Great. Any of the gizmos, those are all models. The all the atomic models that we've done, remember the FET diagrams? Those are all models. All the drawings that I did on the board when we were doing the models, all of those. Anything that we created, when we did all of those little experiments. Hi, Avery. Okay, all those experiments that we did. Hey, is that Kyle? Hey, Kyle. I'm trying to see everyone. I'm trying to see everyone who's popping in. I'm trying to read all the names on the screen while I'm talking. So all of those are models. So we have literally seen dozens upon dozens of models. So any of those are acceptable. Hi, Juliana. It's so good to see you. Oh, I'm so happy to see that. It is so good to see you again. And I hope high school's treating you amazing. That makes me feel so good. Thank you. I have someone from 2 years ago visiting me in the live. Yes. Yeah, she came in the live. All right. I love you too. Have a wonderful night. All right. So, how do science and society help each other? Okay, this question is really, really important. So, Tori, you're not in science yet, in high school yet. I'm hoping we can get you there. Okay. How do science and society affect each other? A lot of students struggle with this question. Okay, science and society help each other because science benefits society in so many different ways. Think about the house that you're currently in, okay? The building structures that you use, the building structures that were used to create the house that you're in, for example. The medicine that is used to help cure you. If you break an arm or a leg or you're injured, the doctors that you go to. Okay, medication that is used to help heal people, the technologies that are used in medicine, technologies that are used in engineering. So science helps build society by helping with the needs of society. Does that make sense? In turn, society's needs helps drive science. Okay? Scientific discoveries are driven by societal needs. Okay? So we feed off of each other. Oh, you're so welcome. So science drives society and society drives science. So they feed off of each other and they come together to basically benefit, and go back and forth. And that's how we grow. Oh, this is my other boy. This is Chance. This is my little old man. I'll let you see him. See, that's my little old man. So, all right. Next. What factors determine science's willingness to change more eco-friendly sources of energy? Well, biggest thing is cost, money. You are so welcome. Okay. How much exactly, Seth? Okay. Oh, you're on that lesson too? All right. Yeah. So money is a huge factor. Okay. So cost, data, new technologies and materials. So lack of resources. So, for example, if you're in Kansas, you might use windmills. You might use solar energy. But you're not going to use hydroelectric power in the middle of Kansas. It's not going to work in Kansas. You might use hydroelectric power. You might use solar power in Florida. You're not going to use windmills in Florida. Okay? So, well, yes, I get that. But what I'm saying is certain forms of eco-friendly power are going to be used in certain places. You're not going to go to Seattle and use something like solar power where you don't get a whole lot of sun. It doesn't make sense. So limitations about the environment are going to prevent certain people from using certain types of eco-friendly types of energy. That's the point I'm trying to make. Does that make sense? So you want to think about where you are in terms of what type of energy sources you're going to use. Okay, yeah, Tori, let's think. You want a house tour of my house? I can show you Stitch and Angel, and I can show you the painting I did, and the other painting I did. Those are my doggies. They're urns, my other babies, and that's about it. That's my mom's urn over there. That's it. That's all you get. I'm not going to get up and run around. Okay, renewable energy is what reduces pollution. Yes, carbon emissions, carbon footprints are extremely important. Well, I would remember you if you actually told me what your name was, because I don't know what little lambda lady is. You have to tell me your actual name. Yes, I remember you, James. Of course I do. All right. Number 11. It's good to see you again, James. See, I have some of my, they're coming back. So I guess you guys are still subscribed to my channel and you saw my live was coming up. All right. The law of reflection states that when light strikes a flat surface and it is reflected, you can draw a line perpendicular to the surface so that the angle of incidence, light moving towards the surface, and the angle of reflection, light reflected away from the surface, will be equal. The angle of incidence, theta 1, is 22 degrees. What is the angle of reflection, theta 2? Tori, you're in my 6th period. Yes, I remember you. So the answer to that is also 22 degrees. You're welcome to do so. Thank you. All right. For each symbol for the movement of light, match the correct form. Tori, please stop. Okay. So for the first one, where it is transmitting straight through, it is C transmission. For the second one, it is E reflection. For the third picture, it is B refraction. For the fourth one, it is A scattering. And for the fifth one, it is D absorption. It's not any different. He trolls me in class too. Why does sound travel faster through metal than through air? Sound travels faster through metal than through air because particles make up metal are closer to each other than particles of air. Okay, I don't know why I'm reading the answer. Okay, so sound is a mechanical wave. It requires particles to move on. Okay, it needs something to carry it. The example I gave in class is kind of like the old style way they used to put out fires, with buckets of water, and you kind of have that assembly line of people standing shoulder to shoulder and they're passing buckets along. Okay, it's so much easier to go from here to here than have people standing really far apart where you kind of have to run the bucket over to someone. It takes so much longer. Okay. The further the particles are apart, the longer it takes for sound to travel. So, if in, let's say, a metal piece, because in this example they gave a metal piece. In a metal piece, the particles are close together. So, because they're in a metal piece, the sound wave will travel faster. In water, the particles are further apart. The sound wave will travel a little bit slower. In air, they're even further apart. Sound waves will travel even slower. And then in a vacuum in space, sound is not going to travel at all. Okay? Tori, why are you putting your business out there for the whole internet to see? You do realize that the entire internet can see this, right? Okay, explain why a satellite orbiting the Earth could use radar to detect other objects, but not sonar. So, same principle, okay? Satellites orbiting the Earth could use radar to detect objects because radar can travel through a vacuum, but sonar requires the medium for waves. Okay? There's no atmosphere in space. Because there's no atmosphere in space, sonar cannot travel. Radar can travel because it's an electromagnetic wave. Okay? If you start the motor of a boat, so we're on number 15 right now. If you start the motor of a boat, who would detect the sound of a motor first? A friend sitting on the shore of a lake or of a fish swimming along the shore of a lake? So, again, the particles of the water are closer together than the particles in air. So the fish in the water would hear it first because the sound would travel faster in the water. Yes, exactly. The fishies, because they're more solid, or the water, the particles are closer together. Okay. Does anyone have any questions so far before I move on? Blasphemy, that's a strong word. A 0. Okay, moving on. All right. So the electromagnetic spectrum. What is the order of the electromagnetic spectrum from the longest to the shortest wavelength? Okay, so this is where that infernal song comes in. So actually, the shortest wavelengths are the gamma rays. So if you know that infernal song, it's radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-ray, and gamma rays. So that is the order from longest wavelength to shortest wavelength. Okay? Yes, your ears are blessed. Now you're going to be singing that song in your head all night long. Okay? I heard about how in show choir they actually did a project on that song. It was awesome. So, what is the relationship between wavelength and wave frequency? Kerfuffle. I'm going to laugh about that word for the rest of the night. Kerfuffle. I am finding this very amusing. Okay. So, what is the relationship between wavelength and wave frequency? The longer the wavelength, the shorter the frequency. The shorter the frequency, or the shorter the wavelength, the longer the frequency. What is the relationship between the frequency of a wave and its energy level? The higher the frequency, the higher the energy level. Yeah, I'm not even going to try to read that. Okay. What wave has the highest energy level? Who wants to write it in the chat? What wave has the highest energy level? Tori, I'm going to mute you in a hot second. What wave has the highest energy level? Nobody wants to guess? Very nice, Seth. Gamma rays. Perfect. Oh, if you list two, what's the other one? The question wants to list two. Gamma rays is definitely the highest. Which one would you list with it? Perfect. Kudos, Seth. All right. What wavelengths of the electromagnetic spectrum overlap each other? Oh, thank you. I appreciate that. Oh, that is so sweet. That makes me feel good. Thank you. All right. So according to the graphic, if you look at the graphic up here in the review, so this picture right here, okay? I'm not going to do a collab with Mr. Sanchez. So microwaves and infrared overlap, ultraviolet and X-rays overlap, and X-rays and gamma rays overlap. The dogs are playing, so I apologize in advance for the barking. For each type of electromagnetic radiation, provide an example of how you encounter it in daily light. So visible light, that's the light that you see. Ultraviolet light causes sunburn. Infrared, that's a heat energy transmitted by radiation, and infrared light is actually what you see in your remote control. You know that little red dot that you see right here in the tip, in that little button in the tip of your remote control? That's infrared light. And X-rays, well, when you go to a doctor, whenever you potentially break a bone or do break a bone, infrared. Not infrared, no. I think my dog has the zoomies. Okay. So we're currently on 22 right now. So you have a diagram of a roller coaster. Okay. According to the diagram below, at which point is gravitational potential energy the greatest? And at which point is kinetic energy the greatest? So, looking at the diagram, okay, gravitational potential energy is the greatest at A, and kinetic energy is the greatest at B. Okay? All right. Use the diagram above to explain how energy is conserved during the roller coaster ride. Okay? The total amount of energy in the system remains constant. And the reason for that, in the beginning of the roller coaster, okay, this is manually pulled up. As you get up here, you're at the top of your gravitational potential energy, right? As you start to drop, you have a loss of gravitational potential as you have a gain in kinetic. But you also lose some energy to sound and thermal. As you get down here, you have no kinetic, and you have all kinetic energy, no gravitational potential. As you come up here, you're losing kinetic energy as you're gaining gravitational potential energy. But again, you do have a loss to thermal and sound as well. As you get up here, you are at max potential, no kinetic. And as you get down here, well, you have a little bit of kinetic. You're not as high up here. We'll talk about that in a second. Here, you have a change to kinetic. Again, you're continuing to lose in thermal and sound. Okay. And then you're ending. All right. So your total amount of energy is the same. Okay. And the reason your total amount of energy is the same is because your energy is not created or destroyed. It's simply being converted to other forms. Okay. What is not kinetic is either potential, sound, or heat. That would be kind of funny. I'd be a millionaire if I had a theme park. I would not be mad at that. Okay. So does that make sense? So the total amount of energy in the system is the same. It's just converted to other forms. And the reason why this cannot be as high as this, and it will never be as high, is because the total energy in the system doesn't go back to gravitational potential or kinetic, because some of it becomes sound and thermal, which doesn't get converted back to gravitational or gravitational potential or kinetic. I'm tired of hearing about Tarpon Springs story. Okay, so so explain how potential and kinetic are related. I just went over it. As gravitational potential decreases, kinetic increases, and vice versa. Okay, so as one goes up, the other goes down. Correct. Inverse relationship. Well said. Good job. All right. So, what's the matter, buddy? Knox, leave him alone. All right. Define and give an example of each form of energy listed below. They're on Canvas. Two of them are due tomorrow night. I think I set them due for tomorrow night, and one of them is due the 22nd. But I would work on them tonight to be safe. Okay. Yeah, you may want to. The two that I extended are due on the 20th. One is due on the 22nd. Okay. So define and give an example of each form of energy listed below. Thermal energy. An example of thermal energy is a hot plate. So it's the total kinetic energy of the particles in the substance. Nuclear energy, that is energy stored in the nucleus of an atom. An example of that is a nuclear reactor. Chemical energy, that's energy stored in the bonds of an atom. And that's energy stored in food. Mechanical energy, the sum of the potential or kinetic energy associated with motion and position of an object. That's a pendulum. Okay. If you don't know what a pendulum is, if you know what a grandfather clock is, that thing that hangs with the little circle that kind of goes like this, that's a pendulum. Okay. Sound, energy from the vibrations of an object. That is sound. Radiant music from a radio. Radiant energy from electromagnetic waves, sunlight. Electrical energy from moving electrons, a wall outlet. Energy. Okay, so electrical energy is caused by moving electrons. Elastic energy, energy from stretching or compressing, a spring, a bow and arrow, all of those. Tori, how is that a threat? Okay, next question. All right. Anyone have any questions on what I've gone over so far? I want to make sure everyone understands. You made popcorn to watch the live. That's kind of hilarious. All right. Number 26. Explain the energy transformations that occur while a flashlight is turned on. Well, the chemical energy in the battery is transformed into electrical, light, and thermal. All right. Define and give examples of conduction, convection, and radiation. Sorry, they are literally right here causing drama. So radiation heat transfers through electromagnetic waves, the fire or microwave. Conduction, heat transferring through direct contact, pot on a stove, for example. And convection, heat transferring through a fluid, liquid or a gas, boiling water, or a lava lamp. Avery, if I had an answer to that, when I figure it out, I'll let you know because I haven't figured it out. So I haven't figured it out yet. All right, so you have a hot cup of coffee placed in a room. Describe the flow of thermal energy as the coffee cools. Draw arrows to show the direction of thermal energy transfer. So you should show energy radiating from the cup, and the heat from the coffee, which is at a higher temperature, transfers from the coffee to the room. Okay. Heat will also flow from the coffee to the cup and from the cup to the room. Okay, so it flows from an area of higher temperature to an area of lower temperature. So, what major types of force could be applied to the following scenarios? So, a tug of war. Anyone tell me what type of force is a tug of war? Or if there's more than one force? It is a contact force, yes. Usually unbalanced. Anything else? It is applied, and usually there is a frictional force involved. Yes, good. Awesome. What about skydiving? On the packet or on the final? Well, the packet, you want a 200. Well, a skydiving. Skydiving is gravitational and frictional. What about separating metals and non-metals? What type of force do you want to apply to that? The easiest way to separate metals from non-metals. Magnetic forces, correct. Good. What about bungee jumping? Gravity. And one more? Elastic. Yes. It's not necessarily, well, hopefully, yes, elastic potential. Yes, because when that bungee cord, it actually stretches and it pulls you back up. You really don't want a contact force, because if you have a contact force involved there, you're not going to survive. That would be bad. Yes, that's a good word for it. That's not a force you want when you're bungee jumping. That would be bad. Yes. All right. So for the Venn diagram, you're comparing contact and non-contact forces. Clean up on the aisle. All right, so contact forces, interactions between objects that touch. You know this happens every night. Well, now you get quiet. Contact forces, interactions between objects that touch. Applied force, spring force, drag force, frictional force, and normal force. Well, honestly, it doesn't bother me that much because the older dog, was really sad when my last dog passed away. And this little one, when he came in, he gave him life again. So I'm okay with it. Pushing a train to save people on the track. Yes. Okay, so that's applied force and frictional force and normal force. And to a certain point, drag force. That's kind of funny. All right, so non-contact forces: magnetic, electrical, and gravitational. Oh, and let me remind you, this is supposed to be recorded and put in, it'll be on the channel so that you'll be able to go back and listen if you need to look at some of the answers. What's up, little buddy? Come on, dude, leave your brother alone. Yeah, that's my Knox. Knox. Oh, okay. All right. I'm not even gonna ask. Are you serious right now? You can't do this behind me while I'm streaming. Okay. What causes friction between two objects? I can't with you guys right now. All right, I'm gonna move on now. Now that I no longer am being attacked by dogs in my back, they were attacking each other behind me and pushing me off the couch. Friction is a force resisting motion of an object when in contact with another. The resistive force is caused by surface roughness of the contact materials. Okay, so I'm reading the answer here because I got completely distracted. I apologize. So basically what that answer says, because I struggle with these answers. What causes friction between two objects? Surface area, the coefficient of friction. What that means is the surface area between the two objects. So for example, if you have ice and ice, they're going to be really slippery with each other. But if you have like concrete and concrete, the surfaces are rough, there's going to be a lot more friction between those two surfaces. So the types of surfaces, the drag between those two surfaces. Isaiah Allen, that is a blast from the past. Hello, Isaiah. So that, those surfaces, sandpaper, that's another surface that is going to cause a great deal of friction. Okay, so the type of surface, the surface area, all of those are going to matter when it comes to the amount of friction you're dealing with. Mass can also be a cause. Okay. What factors? Surface type and mass of object. So that's number 32. List at least two ways to increase friction between the objects. Change the surface type and change the mass. Hi, Joshua. Is Joshua here? Hey, welcome. I'm seeing a lot of my kids from the past. It is so good to hear from you. Tori's back. Okay. Yes, I'm seeing a few of my students from the past coming to visit me. All right, so provide two examples. We want to increase friction and when we would want to decrease friction. So what sport would you want to increase friction in? Oh, you're finishing up your IB homework right now? Very cool. Oh, you wouldn't want to increase friction on track, would you? That I want to decrease friction. Maybe a little bit in hockey. Oh, thank you. I would want to increase a little bit of friction on hockey, not track. I would want to decrease it on track. I could tell you running track, the air hitting my face was painful. Skydiving, I want to increase friction. Any driving sport, I want to increase friction. Track, it's hard to slip on track, especially if you're wearing cleats. There's such a thing as track cleats. So, Diego. Hey, Diego. Wow, I'm seeing a whole bunch of people. It is so good to see you guys. All right. So, but decrease friction, ice skating, you want to decrease friction because you need that speed. And plus your skate can get caught. Flying, you want to decrease friction. Okay. What is the equation for calculating speed? Speed is equal to distance divided by time. Perfect. That's correct, Seth. If a car travels 400 meters in 20 seconds, how fast is it going? Anybody want to tell me? $20 meters per second. Perfect. If you need to get to class 200 meters away and you can only walk in the hallways about 1.5 meters per second, how long will it take you to get there? Anybody want to share? Perfect. 133.33 seconds. How far can you get away from your little brother with a squirt gun filled with paint? If you can travel at 3 meters per second and you have 15 seconds before he sees you. As he types the answer, 45 meters. You are all correct. There's a war going on in the chat. Okay. All right. Draw a graph that represents an object that is moving at a constant speed. All right. So an object that is moving at a constant speed, it's a straight line, diagonal. All right. Draw a graph that represents an object that is accelerating. Now remember, acceleration doesn't just mean going faster. Acceleration and deceleration both mean acceleration, folks. See? See that? Both answers are correct. You know I don't pick favorites. I'm still the same person I was. I don't pick favorites. Draw a graph that represents the following motion. A person walking 5 meters in 10 seconds, then moving 10 meters in 4 seconds. So 5 meters in 10 seconds, then 10 meters in 4 seconds, that person obviously is speeding up. So they start going like this, and then it's a sharp increase. So it looks like that. Oh, we did that page already. All right. Yeah, he does need a ticket. Well, was he driving or was he walking? Walking. I don't know if they give tickets for walking. That's kind of funny. Create a Venn diagram comparing balanced and unbalanced forces. Describe how each can affect an object's motion. Provide an example of each. So, basis for comparison. All right. So, a balanced force. Hello. Welcome. Feel free to tell me your name so I know who we're talking to. So, when a balanced force is when an object's force exerts on the object area of equal size but in opposite direction, and the forces are known as balanced forces. So, in other words, you have an object, both forces on the sides are equal and opposite. An unbalanced force, the forces applied on the object are unequal. Okay? So the direction is opposite for a balanced force. On an unbalanced force, the direction could be the same or opposite. In a balanced force, the object is a stationary object is at rest. In an unbalanced force, it moves in the direction of a greater force. Moving objects on a balanced force, it continues to move at the same speed. In an unbalanced force, it changes speed and direction. Net force is 0 on a balanced force. In an unbalanced force, it is non-zero. Hi, Sue. So what is a net force? A net force is the sum of all of the forces acting on an object. So do you remember when I drew on the board and I said the forces that were up and to the right were positive and down and to the left were negative? Okay. So what we were looking at there. Okay, yeah, we're on question 38, but this will be recorded. So since it'll be recorded, hey buddy. So since it'll be recorded, it'll be put on the YouTube, so you can always go back and look at it later. He just put his ball in my neck. So, oh, I'm sorry. So when you add up all of the forces acting on the object, the ones that go either up or to the right are positive. The ones that go down and to the left are negative. When you add up all of the forces, the sum of the forces are 0. This ball. So the dogs are playing. So, okay. So, what is the total net force if a balanced force acts on an object? The total net force is 0. What is the total net force if an unbalanced force acts on an object? If the forces are unbalanced, the net force on any number is not 0. So draw a force diagram that shows a balanced force. You can draw exactly any number except not 0. So for number 41, as long as the forces are equal and opposite, you're okay. Uh-oh. I noticed there was a stick in my screen there. So here, for example, this is, okay. For me, everything is reversed. This is 5 and 5, and this is 12 and 12. Or two, is it 2 and 2? 2 and 2. So this is 2 and 2, and this is 5 and 5. So as long as it's equal and opposite, it is considered a balanced force. Okay? Yeah, but there has to have forces around it. As long as you have the forces around it that are equal and opposite. So draw a diagram that shows an unbalanced force. As long as the forces are not balanced, as long as they're not equal on the opposite sides. So 5 on one side, 3 on the other, whatever they are, it does not matter. In this case, this one is 90 and 100. I mean, they made them wildly different. So as long as they're different, you're okay. And it doesn't matter what the numbers are. So. And then number 43. What kind of force is gravity? Gravity is a force of attraction between all matter. Okay, it is a pull force. And what influences gravity? What two things influence gravity? I know we're almost to the end of the stream. What two things influence gravity? Mass and distance, correct. In this, how can we take a group photo? We can't see each other. Yes, we will see each other in class tomorrow. How does gravity affect mass? So I know it's going to take a while to type out. So the further apart you are, the less the gravitational pull. The closer together you are, the greater the gravitational pull. And how does gravity affect weight? Okay. Oh, I'm sorry. Woo! I read this completely wrong. How does gravity affect mass and how does gravity affect weight? I completely read that wrong. I was thinking distance in my mind. Mass and distance. Okay. Let me backtrack. This is what happens when you've been working. So gravity does not affect mass. It affects weight. Okay. Mass does not change no matter what. Weight changes because weight is impacted by gravity. The greater the gravitational pull, the greater the weight. That is why on Earth, weight is 3 times greater than on the moon, because the gravitational pull is 3 times greater on Earth than on the moon. What I was thinking in my mind, which I don't know if you have a question on it, and you don't. So I'm gonna add it as a component to 43. You can add it on if you like. What I was going to say was, and it's something you should know, so I'm surprised they didn't include it, but mass and distance, the further apart you are, the greater the less the gravitational pull. The closer together you are, the greater the gravitational pull. The greater the mass of the object, the greater the mass of the objects, the greater the gravitational pull between the objects. The lower the mass of the objects, the less the gravitational pull between the objects. So that's how gravity is balanced between objects. That's the reason why Mercury, for example, can be so close to the sun and Jupiter can't be that close to the sun, because Jupiter is so much more massive. If it got any closer than what it is, it would get sucked into the sun, for example. Who is that? Long time no see, but I don't know who that is. Tell me your name. Alec, you got to give me more information. So you got to give me more information. No, it's not that I don't remember, but you sat with buffoons. That's kind of funny. And you came to see me on the live. I feel so touched. I love my quiet kids though. No, he's not quiet. Tori is not quiet. Don't say that. Well, it is good to see you again. And thank you for coming through. Tori, you give me anxiety every time you come to my class. What do you mean you're not quiet? No, you are not quiet. You stress me out every day. Thank you. You too. How much longer do you guys have? I know high school's a little bit different. I never said this. Oh, Avery, that was awesome. No. I'm going to answer this last question. Compare mass and weight. Oh, didn't we just go over this? Oh, mass is the amount of matter something contains. Weight is the measurement of the pull of gravity on an object. So you use mass is measured using a balance, comparing known matter to the unknown amount of matter, and weight is measured on a scale. Does that make sense? Actually, I like that explanation. Actually, that was the last question. So we are done. I know, Avery. Who knows? Maybe if we have a chance, we could always do another live stream just to kind of go over some fun science facts together once we're done with the insanity. I find that really funny. Summer tutoring? It just ended. It's gonna be Noah. It's gonna be put in the. It's gonna be recorded, or it is recorded. Yeah, we started at like 7:15, so it's recorded. It's gonna be in the. What do you call it? The stream is going to be there, so you'll be able to take a look. So, but it was good. It was good seeing some of my old students come in and say hello. I was really excited to see you guys. And it made me really, it, I was really happy to see everyone come in. Thank you for joining me. And thank you to all of my old students who came in and say hello. That really made me feel good. And thank you to those who came in who are from different schools. I'm glad I could be of help. That meant a lot too. And I'm sorry for my dogs who are this Tory here over here. Okay. Extra. We'll talk, Avery. Come talk to me tomorrow. We'll have a conversation, you and me. Don't you have like a B in my class? You're doing well for me. Let's see how we do on the packet, and let's see where we're going. I don't think you have a C, Seth. Because you need to do my work. Oh, you're not going to stay there. I'm not worried about you, Seth. Well, we could talk about it in class. Let's see what the grades look like, but I know you're not going to stay there. I'm not worried about it. So, but I hope you guys have a wonderful night. Thank you so much. You're not going to stay there, Sue. I already know it. Thank you. Yes, go do that penda. Go get the pendas done. We should make friendship bracelets. I tell you what, the Thursday after exams, you make friendship bracelets. How's that sound? All right. All right. So then I'll tell you what. Once exams are done, we can breathe. All right. So I'll see you guys tomorrow. I really do hope the review was helpful. Oh, are you hearing my dogs? Yeah, I've got the one over here that's causing trouble. There's only one way for me to get him to stop, and that's to make him howl. Knox. That's the only way I can get him to stop. All right. Okay. Yeah. If I wanted to, I can get him to howl. Hi. Who's funny magic man? Do they? Who are you? Oh, hey, Shane. Oh, see, Chihuahuas are the devil's children. They scare me. They're crazy. See, this one's a Basenji. He is an old African breed, but I think he's got a little either boxer or pit bull in him, so he's a little bit mischievous. Knox, come here. Come here. Come say hello. Come say hello. No, I don't. I know you're trying to keep me from going to sleep. Oh, you guys aren't trying to let me leave the school. I'll be there for at least one more year. Yes, he's just a little bit in La La Land. He is. All right, guys. It is time for me to go decompress. Oh God, don't get held back. You don't want to do that. Bye, guys. I hope you have a wonderful night. It was wonderful seeing you. Thank you for coming. More friendship break. Bye. I'll see you tomorrow. Oh dear. Have a great night.